Our ping test started awfully well. Router 2 can ping router 3, router 3 can ping router 4, but as we were kind of suspecting, router 2 cannot ping router 4. They are on different subnets, and version 6 is advanced, but not that advanced. We got to add a little something here, and typically in a network, we know we're going to add a dynamic routing protocol. We're going to use OSPF, RIP, or EIGRP. We're saving those for later version 6 studies, so that kind of leaves us just one solution: static routes. And we have static routes, we have host static routes, we have default static routes. You're going to love the default static route. But first, we got to cover these regular ones. And by regular, I just mean that they are not host routes, which match only one address, and they're not default routes. They're just regular static routes. And the three kinds are recursive, where only the next hop address is specified; directly connected, where only the output interface is specified; and fully specified, where, as you would expect from the name, both the next hop address and output interfaces are specified. So we'll put all three of these into action. We'll take a few routes off at the same time, and we'll begin with a recursive route on router 2. And again, I know you're getting a little tired of hearing this, but just remember that V6, because if you start this with IP route, it's not going to work. And any multiple choice on your exam, if you're asked how to write any kind of route, static route in version 6, the command is not IP route to begin with. That's IP version 4 static routing. This is IP version 6, so we got to use IPv6. Let's get started with that. Check some syntax out along the way. IPv6 route. And let's see, we've got routing for IS to IS. So what does that mean? That means that we're not configuring this on the interface. So there is an IPv6 route command for the interface. Don't use it. And yes, I did plan that. That's my story, and I'm sticking to it. IS to IS is not part of your CCNA studies. It is a link state protocol like OSPF is. But don't worry about it. I showed you that because while I wanted to show you there is an IPv6 route command for the interface level, but that's not what we're using here. We're using IPv6 route in global configuration mode. So let's go ahead and hit that and have a look at iOS help here. And you'll notice it's IPv6 prefix, makes sense. Static VRF, we're leaving those options alone. We're going with the prefix. And this is the prefix for the destination. Just like with the IP route command where you put the destination network first, this is always going to be the destination. And there we go. So you're just putting the first half, you're putting the prefix in, which we know is 2001, then all threes, all fours, and then 1, and then //64. So far, so good. Let's use iOS help here and see what we have here. First off, we have about 300 different kinds of interfaces, or at least it seems that way, a few of which, well, one, we're going to use later. But right now, we're much more interested in that next to last option, which is IPv6 address of next hop. So we're going to put that in, and that would be what now? Which address on router 3 is that going to be? That's going to be the one we pinged earlier. And let's go ahead and bring our diagram back up. That's going to be 2001.2222.33331:3. That's going to be the next hop IP address. So let's go back to the router and we'll plug that in, so to speak. And we're almost there. Actually, for this one, we are there. And this, again, is a recursive static route. Let's go ahead and just enter that one. And we'll run show IPv6 route. And we have our first static route. Now, when you were looking at this table earlier, even though I said the only three were the ones at the very first, connected, local, and static, the only three that we're concerned with in this section, I'm sure you went ahead and looked through the rest of this, and you might have noticed that the asterisk for candidate default is missing. It's not there, and you're just going to see an S here, even with it when this is a static default route, just something you got to get used to. But there's our first static route. It looks awfully good. We see the prefix we're going to, the network we're going to, and we see the next hop IP address. And let's go ahead and try pinging router 4. Yeah, I did kind of put a dramatic pause in there. And this time we're getting something, but we're getting timeouts, which is not good. So I bet you have a pretty good idea, or a really good idea, what's going on right now, why we can't send that ping. But let me ask you this. If we were troubleshooting this, what's the next thing you'd likely do? Let's step away just from verse 6 troubleshooting. If you're trying to ping a destination that you expect to be able to ping and you can't do it, what's probably the next thing you should do? Ping an address that's close to you. Start coming back and see where the trouble is. And what I would do here is ping router 3's interface. Its fast Ethernet interface, that is. And that ping goes right through, as we'd expect. It went through before, so that's no problem. The issue here is that the packets, when they get to 4, they don't know how to get back. So to have end-to-end communication with static routing, not only does 2 have to have a route pointing to 4, but 4's got to have a route pointing to 2. So let's go over to router 4, and we will put in a directly connected static route, which uses only the output interface. That's IPV6 route. We're going to this subnet. And this time we're going to use the interface option. And there are the remaining choices, none of which we want to use. And there we go. So that's all there is to a directly connected static route. Just know the difference between that one and a recursive one, the one value that each of them uses. And let's go ahead and send our ping. And success. Router 4 can ping router 2. You know what we're going to do now, and go ahead and send one from 2 to 4. And that was the previous address. That's the latest one. And now it goes through, and that's just reinforcing a valuable lesson about ping packets, is that it's not enough to see a destination. It's a routing table. It's not enough for the packets to get there. They got to know how to get back. They got to be able to get back. So now we've seen a recursive static route in action, and we've seen a directly connected static route in action. And tell you what, let's go ahead and stay right here. Let's go another couple of minutes, and what I will do is remove the static route that we have on router 2 right now. And we want to see a fully specified route in action. We're going to do that at the beginning of the next video and take a look at some other static route types as well.